It's Carla. Rational exponents are another way for you to show radical expressions, but in exponential form, okay? So there's the exponential form that you can rewrite all the radicals in. Kind of cool, right? Yeah, cool for me. Pain in the butt for you. I get it, but it's all good. So rational exponent. If I go in one go with these highlighters, it doesn't double up on the coloring. So I'm trying to go in one color. All right. Rational. All right. Exponents. For any positive real number, b, any integer n greater than 1 can be written like this, where b from the base of the power, so let me label that. This is the base of a power. This whole thing is a power, or exponential form, of 1 over n, and n has to be greater than 1, and square root of an index. So whatever n is, it's going to be the index, meaning that's how many pieces of identical ones you need in order for you to simplify it out from the radical. So if it's 2, then you need a set of 2 that's identical, right? If it says 4, I need a set of identical 4 pieces that are being multiplied together to but simplify it out of the radical sign, okay? So the b that used to be the base to the power is now called a radicand. No, this is now the radicand. Okay. And the n that used to be the denominator of my exponent, denominator of the exponent, is now the index for the radical. Okay. So examples would be like 16 to the half power. What's my index for my radical sign? Same as the denominator. So I'm going to put 2, but I'm putting it in dotted because it's kind of like 1x. We don't really write 1x. We just need to write x, and we know there's only 1. Does that make sense? So if we have square root, we all know, all the mathematicians in the world already know that it's a square root. It is not a cube root. It's not a fourth root. It's only for square roots that it doesn't have an index there. Okay? So if it doesn't have any index here, that means it's square root. Okay? So square root of 16, that becomes my radicand. What's square root of 16? 4, because I have 4 times 4 as my factors for 16, and I have one pair of 2 identical pieces being multiplied together, right? So that becomes my simplified value of 16 to the half power. How are we doing? Did I explain that it's slow enough? Okay, I'm going to do one more. Here we go. 32 to the 1/5 power. You guys okay? All right. What's my index? 5. So it's the 5th root of what goes in for my radicand? 32. Okay. You want to break down the 32 to factors that we can find a group of 5 in it. Okay. I need to find factors of 32. So like 4 times 8 gets me 32, right? Is there 5 of anything there? I only have 2. So I have 2 and 2. Now I have 3 factors. I'm going to break down 8 again. 4 times 2. Ooh, I can break it down and I get 2. So how many? I have prime factors of 2, 2, 2, 2, 2. 2 to the 5th power gives me 32. So do I have a set of 5 of something? What's that something? Then that's my solution. Equals 2. Does that make sense? You doing okay? So what if there isn't a 1 in the numerator? What if there is another number other than 1? Are there fractions with only 1 as the numerator? No, there's a variety of numbers that we could put there, right? But n has to be a number that is greater than 1, not equal to 1. It has to be greater than 1. Can it be 0? Can you have a fraction with a 0 in the denominator? Ooh, you should all be shaking your heads. You should not be looking at me with questions. You should never, ever have fractions with 0 in the denominator if you want the real solution, okay? Actually, you can't have even an imaginary solution. All right, so if you have a value of m for the numerator and n is a denominator that is greater than 1. If it's 1, then what kind of number does m become? Like if I have 5 over 1, what kind of number is that? 5 over 1. 5. It becomes a whole number, right? Then you're not writing it as a radical ever. If you have a 5 or 20, if you have any number over 1, you're always going to have a whole number, right? That's why it can't be 1. Because the rules don't apply to any whole number exponents when it comes to these radicals. Only fraction exponents have a radical equivalent, okay? So, looking at those, b is still my base, raised to the mth over n power, and n still is the index, but we're raising it to the m power, all of it, with the b being in the radicand position, okay? So we have b and m. You can also write the same fraction this way. Coloring a lot today. And then n power, you could write it over 1 over n to the mth power, okay? Or, I'm going to put a big or here. Or you could write b to the nth power raised to 1 over m. No, sorry. My bad. I did it backwards. M, b to the m power raised to, what happened? Raised to 1 over nth power, like that. You could swap them because you're multiplying power of powers. Do you guys see that on the exponent rules anchor chart over there? If you take x to the a power raised to the b power, you multiply them, right? Doesn't matter which way we multiply. A times b or b times a. That's what I'm showing you here. Okay? So, example. Oh, where's an example? Let's do 27 to the 2/3 power. Okay? What's my radicals index? What's my roots index? 2 or 3? 3! Yay! And then we put the 27 inside. And then we raise it all to the second power. How are we doing? Okay? Let's work our way inside to out. What's cube root of 27? 3 times 9 gets me 27. So break down 9 again. 3 times 3. So do we have a 3 of a single value of number? Yep. It's right here. 3 times 3 times 3 gets me 27. So I'm going to simplify that by writing just 3. I'm raising it to the second power. What is that equal to? 9. Yay. There's the 9. So this equals that. Questions? No? Really? Okay. One more? Or are you guys okay with just one example? Because I'm going to do a gazillion after this. Uno más. Uno más. I've been requested to give you uno más. So that's just part of the anchor chart. And then let's do this one then. Do I want to do that one? Yeah, why not? 16 to the 3 over 2. 3 over 3 halves power. 3 over 2. 16 raised to 3 halves power. There you go. Okay. Index. 2. Radicand. 16. All raised to third power. Okay. Now what? Square root of 16. Yay, 4. All raised to third power is 4 times 4 times 4. This means 4 times 4 times 4. 64 it is. Great job. Okay? You ready? Now that we know our basics, this is 5. It will be any versions of these. There may be some negative exponents on the test. There will definitely be some sort of a fractional power involved, okay? So let's go ahead and get this started. If I have a to the 1 over nth power, nth root of a is written as nth root of a, like so, okay? If I have a to the mnth power, which was on our anchor chart, but I used b instead of a, the nth root of a raised to the power of, to the mth power can be also written like the way that I showed you in the anchor chart. Or you can write it as nth root of a all raised to mth power. Or you can also write it as nth root of a to the mth power inside the radical. You could write it either way. Okay? Questions? I'll explain how that works, okay? All right. What's the index for this x to the 1/4 power? 4. Root of x. Is there 4 of anything in my radicand? Nope, just 1. So I'm done. Whoop. All done. 24 is going to be the radicand to what? Which root? Root? Oh my gosh. What's the index of the root? 3. Do we have 3 of a kind in there somewhere? Let's see. 2 times 12, right? And then 4 times 3, and then 2 times 2. So it looks like I have 2 times 2 times 2 as a group of 3, right? So that one's going to come out to be simplified. And then I have the cube root with who's left behind? 3. That's my simplified form. Okay? If you leave it like this, that'll probably be like 7.5. But once you get to this, that's getting closer to a 9. 9.5. Okay? Questions? Okay. Yeah.
So whenever you're dealing with like so whenever you have like a remainder, you just put in whatever root you had, so you have like a cube root or like.
I guess you could call it a remaining factor, but not a remainder. Does that make sense? So if if I came down to a prime factorization, and among all those factors that I have, if I can't make any groups of 3, those get left behind every time when you're simplifying. Okay? All right. Know that I didn't pull out 8, I pulled out 2. Even though 2 times 2 times 2 is 8, I don't pull out the 8. Cube root of 8 is 2. So you only pull out the 2. Okay? All right. 15x to the half power is going to be square root of 15x. Are we okay? 3 times 5 doesn't have 2 of anything, right? 3 and 5 are my prime factors of 15. X only has 1 x. No one's going to come out. Everyone's going to be stuck. They're all inside the house. Okay? All right. Let's do this one. What's my index? 3. What's my radicand? 7. What am I raising all of this to? 2. So I'm writing this because it's simplified to its simplest form for that radical. I'm not going to do anything within that parenthesis in terms of the operations we're simplifying. It's already simplified. So what I'm going to do is I'm going to take this and multiply it out twice. Then when I do that, it's cube root of 7 times cube root of 7. We doing okay? When you have an identical radical with identical index, then you can put them under the same house, meaning this. I can do cube root of 7 times 7. Okay? What's 7 times 7?
49.
So I have cube root of 49. Can I break 7 times 7 down to a smaller prime factors? Isn't 7 a prime? So you can't really break it down any further. So there's only 2 of a kind, not 3. So they're all stuck being a cube root of 49. You doing okay? Yeah, okay. Cool. Well, I can't wait for you guys to get to logs. This is going to come in so handy. All right, here we go. Let's try this one. I'll change the color a little bit. If you want to go ahead and try, you can. Okay. I'm going to go the long way first, and then I'm going to show you a shortcut way. Okay. So this is going to be square root k to the 7th power, right? That means I'd be writing this out. K times square root of 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 k. Did I get 7? Looks like it. 4 and 3? Yep. Okay, then everybody can go in their one house, right? But if I do put them under one square root house, do you see pairs that can come out and play? That can be simplified out. These 2 will come out and play. These 2 will come out and play. These 2 will come out and play. And one person's going to be left behind at home, right? 1k is going to be left behind. So I have 1k out, 2k's out, 3k's out, and then I'm left with 1k inside the radical. What's k times k times k? K cubed. K cubed times the square root of k. Okay? Ready for the shortcut? Okay. How many whole 1 can you make with 7 halves? 3. And how many halves are left over? That's kind of like saying this, 7 over 2. I'm thinking, once upon a time in middle school, I was told this is 3.5. Yes? Didn't we get 3 whole k's out to play? And left 1/2 power inside the square root, okay? Yeah? Okay, let's try that idea here. Okay? 5 to the 4th power. How many whole 1 can I make with 5 quarters? I have 5 quarters. How many dollars can I make? 1. So I'm going to put the 3 on the outside. And then the 4th root of 3, there's going to be only 1 of them. I'm going to prove it. You don't have to write the proof unless you want to, okay? So this is same thing as 4th root of 3 all raised to the 5th power. Then I would have 4th root with 5 3s inside the house, right? And then within this 5 3s living under the same roof, I can make one group of 4 3s being multiplied together. Then that one's going to come out simplified with 4th root of this 3 being left behind. See? It's the same. You see it? Nobody writes mixed numbers as an exponent. No one. You think it, but you don't write it. Okay? That's why I put thought bubbles. I didn't put like that equals to this. I'm thinking. Okay? Thinking bubble. 5/4 equals to 1 1/4. So I'm going to have a whole 1 power of this 3 and have 1 left over of the quarter root. Does that make sense? Okay. Let's try this one. 4th root of AB all raised to the 3rd power. Or you can write 4th root of AB in parentheses with 3 inside the radical. It means the same thing. Or you could say 4th root of A cubed, B cubed. Nobody comes out because 3 of a kind doesn't make 4 of a kind. So everybody stays inside. But any of these are all correct answers. Okay? Questions? Your head, because we're not even at the operation ones yet. This is just simplifying. Algebra 2. Welcome to Algebra 2. All right. What's the index? Cube root. Thank you. And then we have negative 6x all raised to squared or 2nd power. Yes? I got 2 of those. Can I have a negative for a cube root? Yes. Can I have a negative for an even root? No. Okay. All right. So I have 2 of those. Cube root of negative 6x times negative 6x. I could put it under the same house, right? What's negative 6 times negative 6? 36. 36. X times x? X squared. Do we have 3 of anything there? 12 times 3. And then 12 is 4 times 3. That would give me 2 times 2 times 3 times 3. Am I right? 6 times 6 is 36. So 6 has factors of 2 and 3. Another 6 will be 2 and 3. So there's only one set of 2 2s and another set of 2 3s. Yes? Do you want me to write it out? 6 and 6, break it down. I get 2 and 3 and 2 and 3. These are my factors, but are there 3 of anything? There's only 2 of each, right? So nobody's going to come out to play. This is it. Nothing can be simplified further, so you leave it as cube root of 36x squared. Okay? Is 7 inside or outside of the parentheses there? then we put it on the outside of the radical. Okay? So if I put it on the outside of the radical, it's going to look like this. And then the square root with 12w inside the radical as radicand. What are the factors of 12? 4 and 3. 4 can be broken into 2 times 2. So do we have 2 of a kind? I have 2 2s, right? So that one can come out and play, but 3 has to stay, and so does w. So if it comes out to play, what do we do with the 7? Do we add it to 7 or multiply it to 7? Multiply, and we have 3w left. So this is going to equal 14 square root of 3w. We're doing okay? I know, it's a lot. We got 5 minutes left, but I haven't even finished this lesson. But I will see you on Thursday, right?
Yeah.
So how about we stop here and I'll continue on Thursday. Is that okay? Yes. All right, okay.